Hello students, this is lesson 1.2.4, first grading period, second week, fourth lesson. It's Thursday, and this lesson is on absolute value equations. I want to review just what absolute value is with you. This is something that we teach in middle school, but you might not remember what it means. The absolute value is of any number x written as, and then you've got these bars like this, and your x or your number goes in between those bars, so it looks like that. It's a distance, so it's the distance of the number from 0 on a number line. Now I want you to think about distance. If you're driving and you drive to Charlotte, for example, and then you drive back to the same place you started, does that mean you went 0 miles? No, you went how many ever miles there and then the number of miles back. Just because and I want to show you, if you look at like a number line, here's 0, and let's say this is 5 and negative 5. So if I go from 0 to 5, I've gone 5 units. If I go from 5 back to 0, that doesn't mean I've gone 0 units. That means I've gone 10 units. So the same thing with the negative 5. If I go from 0 to negative 5, that's still 5 units. So it's the number of places from 0 a number is. So that means the absolute value of 5 would be 5. Let me put that over here. How far is 5 from 0 on the number line? It's 5 units. So this number right here is how many places from 0 is it? The absolute value of negative 5 would also be 5. So the biggest thing you need to remember is no matter what number is in here, it's going to be the positive value of that number. So if x equals the absolute value of 5, then x equals 5. If we're talking about the absolute value of a number equals 5, well, that number could be either 5 or negative 5. So if I said, what's the absolute value of a number is 5, well, that number could be 5 that goes in there, or it could be a negative 5 that goes in there. So we're going to talk about absolute value equations today, but one thing we need to know is, like this one right here, this example right here, if we said the absolute value of a number is negative 5, that cannot happen. That can never happen. Absolute value can never be a negative number because you can't go a negative distance. That'd be nice if you could, because like if you drove your car 5 miles down the road and then you drove back in reverse, it'd be nice if you had negative or 0 miles on your car after you drove back, but it doesn't happen that way. So again, the main thing I want you to remember is no matter what number is in this absolute value, it's going to be the positive version of that number. But if we talk about the absolute value of some number is 5, that number could be a 5 or it could be a negative 5, because if I put a negative 5 in there, the distance is still 5. All right, let's move on. Okay, so absolute value equations. What I'm going to do is I'm going to show you how to solve absolute value equations. I want to talk to you about it in a minute. The absolute value of x equals b implies that x could either be b or it could be a negative b. So if I said the absolute value of x equals 3, well, I could have a negative 3 in there. So x could be negative 3 or it could be a positive 3. So there's two values that it could be. Why is that? Because the absolute value of a number is the distance from 0. So if I said the absolute value of some number is positive 3, then it could be a negative 3 or it could be a positive 3. Why is it that way? Let's see, how do we want to answer that? Let's look over here. Let me draw this graph. Here's 0, negative b, and I'm talking about this right here, and this is positive b. Either one of these would be b units from 0. So we're going to say x is a number that is either B units to the right or to the left of 0 on the number line. All right, so let me just talk to you about solving absolute value equations because that's really what this lesson is. So there's a process to this. It's not too difficult, but I'm just going to take you through the steps. Okay, so if you have an absolute value equation that looks like this, so you have an equation, but you have absolute value symbols within that equation. Okay, so what you need to do is write your equation. That's your first step. Simplify the absolute value so that the absolute, and AV, when we write AV, that stands for absolute value. So that the AV symbol, in other words, the part with those bars, those AV bars, is on one side of the equation and everything else is on the other side of the equation. In other words, isolate the AV symbol. So isolate this part of that equation. So what I usually tell my students to do, let me see if I have a highlighter over here. I think I do. I'll get a different color. What I usually tell my students to do is think of this part right here as its own term. Okay, so like it's like a variable or something. You're trying to get this part in this green square, this green rectangle, by itself. And it's actually exactly like if you had the equation 2n plus 4 equals 10. So the n is like what's in the rectangle. Okay, so you're trying to get the n by itself. It behaves exactly the same way. So what I'm going to do is I'm going to subtract 4 and then divide by 2. All right, so if I subtract 4 on both sides, and I'm going to do this down here, switch back to red. If I subtract 4, then I have 2 times absolute value 3x minus 5 equals 6. So I subtracted 4 on both sides. Okay, now I'm still trying to get this part by itself. And to do that, if I want to get this part by itself, I need to divide both sides by 2. So I'm going to divide by 2. And then that cancels right there. And then I'm left. And don't take this out of the absolute value symbols. Not yet. So absolute value of 3x minus 5 equals 3. At this point, this is where I can separate this into two different equations and take this out of the absolute value symbol. So let's come over here. Set the expression that is inside the absolute value symbol equal to the other side of the equation, and then set it equal to the opposite of what's on the other side. Let me show you what I mean by that. So what I'm going to do is now I'm going to take this out of the absolute value symbol. I don't want to do that until I get it isolated. So now I'm going to set it up 3x minus 5 equals 3. And then I'm also going to set it up 3x minus 5 equals the opposite of 3. Because up here at the top, remember we said whatever's in here could be a 3 or it could be a negative 3. So that's the way we need to set it up, because there are two solutions most of the time to these types of equations. All right, so let's solve both of these. So I'm going to add 5 to both sides. That's 3x equals 8. I'm going to end up with a fraction, but that's fine. Divide by 3. We just leave it. X equals 8/3. And on this side, I'm going to add 5 to both sides. That ends up 3x equals 2. Divide by 3. X equals 2/3. So I have two solutions. One of them is 8/3 and one of them is 2/3. So we could say 8/3 or 2/3. Before we move on, let's just review those steps again. I need to isolate the absolute value. That is like the most important thing before you break up this thing into two equations. Okay, so isolate the absolute value, get it by itself. So again, this is just like this was an x or by itself or an n by itself. So you isolate that and then you take it out of the absolute value symbols and you set it up exactly like it looks on one side, and then on the other side, take the opposite of this thing and put it there. Let's work another one. So we've got, I'll give you some more examples. That was just part of the steps, so we're going to skip that. All right, so let's look at these examples. Okay, so the first one, this one, the absolute value is already isolated. So all I have to do is set this up, x equals 4 or x equals -4, and that's it. That's the answer, okay? On this one, the absolute value has not been isolated yet. I need to get that right there by itself. So what I'm going to do is I'm going to subtract 17 from both sides. Leave it in the absolute value, equals -7. And then I'm going to set it up two ways. This is where I take it out of the absolute value symbol, x equals -7, and x equals, and then I take the opposite of that, +7. And that's my answer, because there's nothing else to solve. All right, so this one, the absolute value is isolated already. So I can go ahead and break this into two equations, x plus 1 equals 2, and x plus 1 equals -2. So then subtract 1, x equals 1, subtract 1, x equals -3. And that's it. All right, so this one's a little bit more involved. I want to get this right here by itself. So I'm going to add 5 to both sides. I'm going to leave this in the absolute value for one more step, and that equals 18. And this is where I break it up into two equations because I've got this by itself. So now I'm going to break it up into two equations. This part gets written exactly the same way. I just take the opposite of this, -18, and then I solve. So subtract 9, x equals 9. Subtract 9 here, x equals -27. Okay, so the next one, the absolute value is already isolated. So I can set it up, x over 2 equals 5. And on the other side, x over 2 equals -5. And then solve. So I just need to multiply the 2 times the 5 here, x equals 10. And over here, x equals -10. This one I need to isolate this part right here. So I'm going to add 7. So don't take it out of the absolute value until you've gotten it all by itself. That's going to be 13. And then I need to divide by 5. I'll write this over here. Absolute value of x equals 13/5. We'll just leave it like that. And then I can take it out of the absolute value. X equals 13/5. X equals -13/5. Okay, let's do some more examples. This just takes some practice. Again, first step, first thing you got to do is get this by itself. I found my highlighter. So I need to get this right here by itself. If I can make that. Make it a little darker. That needs to be by itself. I'm going to highlight all of these. Okay. Now I'll go back to my drawing. Okay, so the highlighted part needs to be by itself. That means I need to add 4 to both sides. Leave it in the absolute value for one more step. Okay, now break it into 2. Take it out of the absolute value. X plus 6 equals 4. And x plus 6 equals -4. And then solve both sides. Subtract 6, x equals -2. Subtract 6, x equals -10. Okay, I would encourage you to pause your video for a minute and try this one and then come back. Okay, so hopefully you paused your video and you subtracted 4 from both sides at first and got this part by itself. And then you take it out of that and you set up two equations. With the -4 being here and +4, the opposite of that being over here. And then solve both sides. This is going to be add 3. X equals -1. And add 3 on this side. x equals 7. Okay, so try the same thing with this one. Try to pause your video and then come back and see if you got it. Okay, so if you paused your video and tried this, you would have isolated this part and by adding 1 to both sides, and then set up the 2 different equations. And with the 1/2 x, what you want to do is multiply times 2 over 1. This is the same as x over 2. So multiply times 2 over 1 on both sides, 2 on this side, same thing. And you get x equals -8 or x equals -12. All right, let's do the same thing for this one. Pause your video and try it. We need a lot of practice on this because we've never seen it before. So I just noticed something on number 2 that I didn't notice before. If you have an absolute value equals a negative number, this is no solution. So once you isolate the absolute value and you see that it's a negative number on this side, you can stop there. So go back to that part and take out what we had put below that. I just didn't notice it before. So go back and take out what you can do is click select if you're doing this on the PDF, and then select annotations, and you can put a box around it and hit backspace, and it'll take the whole thing off. So, all right, so now pause your video and try number 4. Okay, so hopefully you got x equals -4 or x equals -10 on this one. So you had to isolate this part right here by subtracting 9 and then dividing by -3, and then you set up your 2 equations, equals 3 and equals -3, and then solve those. Okay, number 5. So we already have the absolute value isolated, but what we need to do is kind of think of this as in parentheses, because that's going to make it easier for us to do the opposite. So we have this isolated, so we're going to take it out of the absolute value symbol and write it exactly like it looks. Now on the other side, we're going to do the same thing on the left. 4x minus 1 equals, we need to do the opposite of this whole thing. So when we do that, we got to kind of distribute that negative into there. So that's going to be -2x minus 9. So both of those things become the opposite. So let's solve. Subtract 2x, add 1. That's going to be 2x equals 10. So x equals 5. And then over here, I'm going to add 2x and subtract 1. That's going to be 6x equals -10. Oh, sorry, that was supposed to be add 1. All right, so this is -8. So divide by 6, x equals -8/6. I'm going to simplify that. -4/3. So x equals 5 or x equals -4/3. So be careful if you see something like this on the right side that you change everything to the opposite of what it was, or look at it in parentheses. Okay, so again, my absolute value is isolated, so I can set up my 2 equations. 2x plus 12 equals 4x, and 2x plus 12 equals -4x. Here's what I'm going to subtract the 2x over here. So 12 equals 2x, and x equals 6. That's going to be 12 equals -6x, -2. So x equals 6 or x equals -2. This one, if you were to actually check your answers, this answer actually wouldn't work. So mark this one out, because that one wouldn't work if you put it in up here and checked it. Okay, I'm going to do a couple more, and then I'm going to leave well, actually, I take that back. I'm going to do all of them. I'm just going to go kind of fast so you can pause if you need to. Okay, let's isolate the 6x minus 12 in absolute value. We're going to subtract 5. Excuse me, and then divide by 3. That's 18. Then I'm going to set up my 2 different equations. Divide by 6, x equals 5. And let's see, 6x equals, that's going to be negative 6. X equals negative 1. So x equals 5, or x equals negative 1. All right, so on this one, I've got to add 7 first. Let's see, that's going to be 24. And then if you have a fraction like this, you want to divide by 1/2, which means multiply times 2. So that gets rid of that right there. Now I can set up the 2 equations. We'll just put a decimal for that, 4.6. Okay. All right, pause your video and see if you can get the next one. Okay, so hopefully you didn't get too far with that one, because if you get an absolute value equals a negative number, that is no solution. You can stop right there when you isolate the absolute value and then there's a negative number over here, just stop. It's no solution because you can't have an absolute value of a number that is a negative number. All right, pause your video again. On this one, you're going to add 34 and then you're going to multiply times 5. I'll tell you that, but pause your video again to see if you can get this one. So in this one, you would add 34 over here and get 30. Then you multiply times 5 on both sides, get 150 over here, and then you divide by 2 on both sides, and so you get absolute value expression equals 75, and then break it up into 2 equations, 75 on one and negative 75 on the other one, and then solve for x, and you get 14 and negative 11. Okay, so your practice on this, your classwork on this is going to be an IXL, and I am going to do a short help video for you on that IXL. At the Canvas conference today will just be an office hour sort of thing where you can ask questions if you have questions, because I'm going to do a help video on the IXL and post that with your IXL assignment. So you can watch that video if you want before you get started, or you can go on and just go try the IXL. And if you want to pop in during the Canvas conference time, it'll just be office hours, and you can come in and ask me questions if you have them. But I'm not going to be working through a classwork today during the live lesson Canvas conference.